Elementary mathematics consists of mathematics topics frequently taught at the primary or secondary school levels. The most basic topics in elementary mathematics are arithmetic and geometry. Beginning in the last decades of the 20th century, there has been an increased emphasis on problem-solving. Elementary mathematics is used in everyday life in such activities as making change, cooking, buying and selling stock, and gambling. It is also an essential first step on the path to understanding science. In secondary school, the main topics in elementary mathematics are algebra and trigonometry. Calculus, even though it is often taught to advanced secondary school students, is usually considered college-level mathematics topics. According to a survey of the math curriculum of countries participating in the TIMSS exam, the following topics were considered important to the elementary curriculum by at least two-thirds of the highest-performing countries. Whole numbers. The whole numbers are those used for counting and ordering. In common language, these purposes are distinguished by the use of cardinal and ordinal numbers, respectively. A third use of natural numbers is as nominal numbers, such as the model number of a product, where the natural number is used only for naming. Properties of the natural numbers such as divisibility and the distribution of prime numbers are studied in basic number theory. Another part of elementary mathematics. Elementary mathematics focuses on the operations and the properties. Closure under addition and multiplication. For all natural numbers A and B, both A plus B and A times B are natural numbers. Associativity. For all natural numbers A, B, and C, A plus equals plus C and A times times C. Commutativity. For all natural numbers A and B, A plus B equals B plus A and A times B equals B times A. Existence of identity elements. For every natural number A plus 0 equals A and A times 1 equals A. Distributivity of multiplication over addition. For all natural numbers A, B, and C, A times equals plus. No non-zero zero divisors. If A and B are natural numbers such that A times B equals 0, then A equals 0 or B equals 0. Measurement units. A unit of measurement is a definite magnitude of a physical quantity, defined and adopted by convention or by law, that is used as a standard for measurement of the same physical quantity. Any other value of the physical quantity can be expressed as a simple multiple of the unit of measurement. For example, length is a physical quantity. The meter is a unit of length that represents a definite predetermined length. When we say 10 meters, we actually mean 10 times the definite predetermined length called meter. The definition, agreement, and practical use of units of measurement have played a crucial role in human endeavor from early ages up to this day. Different systems of units used to be very common. Now there is a global standard, the International System of Units, the modern form of the metric system. Fractions. A fraction represents a part of a whole or, more generally, any number of equal parts. When spoken in everyday English, a fraction describes how many parts of a certain size there are, for example, 1/2, 8/5, 3/4. A common, vulgar, or simple fraction consists of an integer numerator, displayed above a line, and a non-zero integer denominator, displayed below that line. Numerators and denominators are also used in fractions that are not common, including compound fractions, complex fractions, and mixed numerals. Like whole numbers, fractions obey the commutative, associative, and distributive laws, and the rule against division by zero. Equations and formulas. A formula is an entity constructed using the symbols and formation rules of a given logical language. For example, determining the volume of a sphere requires a significant amount of integral calculus or its geometrical analog, the method of exhaustion, but, having done this once in terms of some parameter, mathematicians have produced a formula to describe the volume. This particular formula is V equals 4/3 pi r3. An equation is a formula of the form A equals B, where A and B are expressions that may contain one or several variables called unknowns, and equals denotes the equality binary relation. Although written in the form of proposition, an equation is not a statement that is either true or false, but a problem consisting of finding the values, called solutions, that, when substituted for the unknowns, yield equal values of the expressions A and B. For example, 2 is the unique solution of the equation x plus 2 equals 4, in which the unknown is x. Data representation and analysis. Data is a set of values of qualitative or quantitative variables. Restated, pieces of data are individual pieces of information. Data in computing is represented in a structure that is often tabular, a tree, or a graph. Data is typically the result of measurements and can be visualized using graphs or images. Data as an abstract concept can be viewed as the lowest level of abstraction, from which information and then knowledge are derived. Basic two-dimensional geometry. Two-dimensional geometry is a branch of mathematics concerned with questions of shape, size, and relative position of two-dimensional figures. Basic topics in elementary mathematics include polygons, circles, perimeter and area. A polygon that is bounded by a finite chain of straight-line segments closing in a loop to form a closed chain or circuit. These segments are called its edges or sides, and the points where two edges meet are the polygon's vertices or corners. The interior of the polygon is sometimes called its body. An n-gon is a polygon with n sides. A polygon is a two-dimensional example of the more general polytope in any number of dimensions. A circle is a simple shape of two-dimensional geometry that is the set of all points in a plane that are at a given distance from a given point. The center, the distance between any of the points and the center, is called the radius. It can also be defined as the locus of a point equidistant from a fixed point. A perimeter is a path that surrounds a two-dimensional shape. The term may be used either for the path or its length. It can be thought of as the length of the outline of a shape. The perimeter of a circle or ellipse is called its circumference. Area is the quantity that expresses the extent of a two-dimensional figure or shape. There are several well-known formulas for the areas of simple shapes such as triangles, rectangles, and circles. Rounding and significant figures. Rounding a numerical value means replacing it by another value that is approximately equal but has a shorter, simpler, or more explicit representation. For example, replacing £23 4,476 with £23.45, or the fraction 312 937 with 1/3, or the expression square root 2 with 1.414. Rounding is often done on purpose to obtain a value that is easier to write and handle than the original. It may be done also to indicate the accuracy of a computed number. For example, a quantity that was computed as 123,456 but is known to be accurate only to within a few hundred units is better stated as about 123,500. The significant figures of a number of those digits that carry meaning contributing to its precision. This includes all digits except all leading zeros, trailing zeros when they are merely placeholders to indicate the scale of the number, and spurious digits introduced, for example, by calculations carried out to greater precision than that of the original data, or measurements reported to a greater precision than the equipment supports. Estimation. Estimation is the process of finding an estimate, or approximation, which is a value that is usable for some purpose even if input data may be incomplete, uncertain, or unstable. The value is nonetheless usable because it is derived from the best information available. An informal estimate when little information is available is called a guesstimate, because the inquiry becomes closer to purely guessing the answer. Decimals. A decimal fraction is a fraction the denominator of which is a power of 10. Decimal fractions are commonly expressed without a denominator. the decimal separator being inserted into the numerator at the position from the right corresponding to the power of 10 of the denominator, e.g., 8/10, 83/100, 83/1000, and 8/10,000 are expressed as 0.8, 0.83, 0.083, and 0.0008. In English-speaking, some Latin American and many Asian countries, a period or raised period is used as the decimal separator. In many other countries, particularly in Europe, a comma is used. Percentages. A percentage is a number or ratio expressed as a fraction of 100. It is often denoted using the percent sign, percent, or the abbreviation PCT. A percentage is a dimensionless number. For example, 45% is equal to 45/100ths, or 0.45. Percentages are used to express how large or small one quantity is relative to another quantity. The first quantity usually represents a part of, or a change in, the second quantity. For example, an increase of 15 cents on a price of $2.50 is an increase by a fraction of 0.15. 2.50 equals 0.06. Expressed as a percentage, this is therefore a 6% increase. While percentage values are often between 0 and 100, there is no restriction and one may, for example, refer to 111% or minus 35%. Proportions. Two quantities are proportional if a change in one is always accompanied by a change in the other, and if the changes are always related by use of a constant multiplier. The constant is called the coefficient of proportionality or proportionality constant. If one quantity is always the product of the other and a constant, the two are said to be directly proportional. X and Y are directly proportional if the ratio is constant. If the product of the two quantities is always equal to a constant, the two are said to be inversely proportional. X and Y are inversely proportional if the product is constant. Analytic geometry. Analytic geometry is the study of geometry using a coordinate system. This contrasts with synthetic geometry. Usually the Cartesian coordinate system is applied to manipulate equations for planes, straight lines, and squares, often in 2 and sometimes in 3 dimensions. Geometrically, one studies the Euclidean plane and Euclidean space. As taught in school books, analytic geometry can be explained more simply. It is concerned with defining and representing geometrical shapes in a numerical way and extracting numerical information from shape. Numerical definitions and representations. Transformations are ways of shifting and scaling functions using different algebraic formulas. Negative numbers. A negative number is a real number that is less than 0. Such numbers are often used to represent the amount of a loss or absence. For example, a debt that is owed may be thought of as a negative asset, or a decrease in some quantity may be thought of as a negative increase. Negative numbers are used to describe values on a scale that goes below 0, such as the Celsius and Fahrenheit scales for temperature. Exponents and radicals. Exponentiation is a mathematical operation, written as Bn, involving two numbers, the base b and the exponent n. When n is a natural number, exponentiation corresponds to repeated multiplication of the base. That is, Bn is the product of multiplying n bases. Roots are the opposite of exponents. The nth root of a number x is a number r which when raised to the power n yields x. That is, where n is the degree of the root. A root of degree 2 is called a square root and a root of degree 3, a cube root. Roots of higher degree are referred to by using ordinal numbers, as in 4th root, 20th root, etc. For example, 2 is a square root of 4, since 22 equals 4. Minus 2 is also a square root of 4, since 2 equals 4. Compass and straight edge. Compass and straight edge, also known as ruler and compass construction, is the construction of lengths, angles, and other geometric figures using only an idealized ruler and compass. The idealized ruler, known as a straight edge, is assumed to be infinite in length, and has no markings on it and only one edge. The compass is assumed to collapse when lifted from the page, so may not be directly used to transfer distances. More formally, the only permissible constructions are those granted by Euclid's first three postulates. Congruence and similarity. Two figures or objects are congruent if they have the same shape and size, or if one has the same shape and size as the mirror image of the other. More formally, two sets of points are called congruent if, and only if, one can be transformed into the other by an isometry, i.e., a combination of rigid motions, namely a translation, a rotation, and a reflection. This means that either object can be repositioned and reflected so as to coincide precisely with the other object. So two distinct plane figures on a piece of paper are congruent if we can cut them out and then match them up completely. Turning the paper over is permitted. Two geometrical objects are called similar if they both have the same shape, or one has the same shape as the mirror image of the other. More precisely, one can be obtained from the other by uniformly scaling, possibly with additional translation, rotation and reflection. This means that either object can be rescaled, repositioned, and reflected, so as to coincide precisely with the other object. If two objects are similar, each is congruent to the result of a uniform scaling of the other. Three-dimensional geometry. Solid geometry was the traditional name for the geometry of three-dimensional Euclidean space. Stereometry deals with the measurements of volumes of various solid figures including pyramids, cylinders, cones, truncated cones, spheres, and prisms. Rational numbers. Rational number is any number that can be expressed as the quotient or fraction pq of two integers, with the denominator q not equal to 0. Since q may be equal to 1, every integer is a rational number. The set of all rational numbers is usually denoted by a boldface q. Patterns, relations and functions. A pattern is a discernible regularity in the world or in a man-made design. As such, the elements of a pattern repeat in a predictable manner. A geometric pattern is a kind of pattern formed of geometric shapes and typically repeating like a wallpaper. A relation on a set A is a collection of ordered pairs of elements of A. In other words, it is a subset of the Cartesian product A2 equals A times A. Common relations include divisibility between two numbers and inequalities. An example is the function that relates each real number x to its square x2. The output of a function f corresponding to an input x is denoted by f. In this example, if the input is -3, then the output is 9, and we may write f equals 9. The input variable are sometimes referred to as the argument of the function. Slopes and trigonometry. The slope of a line is a number that describes both the direction and the steepness of the line. Slope is often denoted by the letter m. Trigonometry is a branch of mathematics that studies relationships involving lengths and angles of triangles. The field emerged during the 3rd century BC from applications of geometry to astronomical studies. United States. In the United States, there has been considerable concern about the low level of elementary mathematics skills on the part of many students, as compared to students in other developed countries. The No Child Left Behind program was one attempt to address this deficiency, requiring that all American students be tested in elementary mathematics.